Send it.
This is our Djibouti to Yemen bridge pitch. I'm Nicholas Veneziani.
I'm Matthew Sparks.
And I'm Tony DeNova.
So there's current challenges with just having maritime-only transport. It's very expensive and it's very risky and takes a very long time to travel from Yemen to the Horn of Africa. There's a lack of stable electricity and water infrastructure within those ports, and there's economic instability that contributes to ongoing conflict in those areas. So by building this bridge from the Horn of Africa to Yemen, we can create benefits such as a land link for sustainable trade, and it starts a foundation for 2 coastal cities, one in Djibouti and one in Yemen. We can also integrate pipelines and power lines that provide life-sustaining resources like fresh water, crude oil, and electricity on demand through that bridge, and provides up to 65% quicker transportation compared to sea routes. And it also has an estimated 100,000 daily passengers between the trains and the cars that will travel on that bridge. It also supports the creation of over 2.5 million jobs across the Horn of Africa within those coastal cities and within building the bridge.
So this is going to be the overall blueprint design. So we're going to go with a suspension bridge from the island of Mayoun to Djibouti. It's going to be a 12.7 mile span. And then from the island of Mayoun to Yemen, we're going to go with the beam bridge. It's going to be about 2.16 miles or so. And this is going to allow for, cargo ships to still pass under the bridge, and, allow for that trade to continue.
So some of the materials that we're going to use for these bridges, we're going to use high performance concrete that's formulated with fly ash and silica fume, which resists the chloride exposure and corrosion from the salt water, and it'll also be supported with stainless steel rebar. We're going to use galvanized suspension cables, which are high tension steel cables with an internal dehumidification system, which uses dry air pumped through the cables to stop corrosion and from getting wet. And then seismic bearings, it's an advanced damping system at the pylon bases that protect against the high tectonic activity that's in those areas.
So here we have a resource quantification. So for the resources, we have a deck area, concrete, structural steel, main cables, and then the towers and piers. So here we have segment 1, Djibouti to Mayoun. This is the long suspension bridge. For the deck area, we have approximate 6,705,600 square feet of deck area, estimated about 115,000 cubic yard of concrete. The structural steel would be about 1 million tons. And then the main cable there's 2 cables. It's at a length of 12.7 miles each. And then the towers would be around 8 to 12 towers for the suspension bridge. And then our segment 2 is the Mayoun Island to the Yemen. This is the smaller beam bridge, the 2.16 miles approximate. The deck area for this is about 1,140,500 square feet of deck area. We have about 18 cubic yards of concrete. Then we have structural steel around 60,000 tons. Then there is no cables for this, as it's not a suspension bridge, it's a beam bridge. Then we have roughly around 50 through 80 piers. So for the total project, when you add all that stuff up, we have a deck area of 7,846,100 square feet of deck area between both bridges. And the concrete, we have 133,000 of cubic yards. And then we have 1,060,000 tons of structural steel, 2 main cables, once again only for the suspension bridge at 12.7 miles each. We have 8 to 12 towers, and then for the beam bridge, we have 50 to 80 piers. So here we have a cost cost estimate for the segment 1. This is the suspension bridge, roughly about for the deck area $2.68 billion. Then for the concrete, you have $17 billion. Then you have $3 billion for the structural steel, and then $750 million for the 2 main cables. And then for the tower and piers, this would be the towers at $2.5 billion. And then here we have the cost segment 1. This is for the beam bridge. We have a $0.46 billion for the deck area, we have $3 million for the concrete. And then for structural steel, we have $0.18 billion. There's, once again, no cables for the beam bridge, so that doesn't apply to this. And for the towers, we have $0.8 billion for the towers. So total cost for everything, we estimated about 3.14 for the deck area, 20 billion for the concrete, 3.18 billion for the structural steel. The main cables around 750 million, and for towers and piers, 3.3 billion. Here we just have a notes. So our deck areas, our width is 100 feet. This is saying for this suspension bridge, it requires a lot more concrete, a lot more volume. Then for the structural steel, our suspension cables are steel that has all many fabrics of the steel line. And this also goes for the tower, steel deck, and beams. And then for the main cables is 1,000 of steel strands per cable. And then towers and piers, we have the beam bridges uses more piers. Here we have the project timeline for the phases. For phase one, we have roughly about half a year to get the final approvals and the mobilization of going to that site. We have, final government sign off, funding released to give everyone the funding of who's going to get paid, the bonds, everything is like that. Then you have the project kicked off, everyone going and mobilizing and planning on what they're going to do, start from phase one and more. And then now you have phase two. This is about 1.5 to 2 years. This is where you have the design engineer who's going to design the engineer, do the marine and geotechnical surveys, and then get an estimate of the materials and construction planning. Phase three is the land estimate and permits. So the environmental permits and regulatory approvals, make sure everything is in order, not doing any endangerment to wildlife. And then we have utility relocation and infrastructure planning. Then you have phase four of construction. This is going to be the long years, 5 to 6 years we're anticipating, just because of how long the bridge is going to be. We have the foundation and deep water work, the tower cables and deck work, and then the roadway connection. And then the last phase, this is testing open in about a half a year. We have the structural and load testing for the bridges, safety inspection, make sure everything's safe for everyone, for the public, and then bridge open to the public so everyone can use it.
So our conclusion, how is this going to improve, the two, both countries involved? So transportation improvement, is gonna heavily improve transportation, going across Djibouti and Yemen. It's going to be massive trade opportunities, not only for maritime, but, also on land as well. Massive increase in jobs, 2.5 million new jobs will be created for this bridge, as well as maintenance for the bridge, and building the two cities that are planned as well. And then, just the creation of new cities and opportunities in those cities as well.
That's the end.
Sorry, I can edit this.